All right, so we're going to be taking a look at Pascal's triangle. Ooh. Okay, and we're going to use it to help us solve binomial theorem. Okay, so we should have already seen that video kind of demonstrating just the generalness of Pascal's triangle. So let's take a look. We'll start off in row 0. Okay, so essentially you can also imagine that there's pretend zeros right here. You would add those numbers together and you would 0 plus 1 is 1 and 0 plus 1 is 1. So I have 1 and 1. Same thing, you can imagine there's zeros. You add all those together and you're going to get 1, 2, 1. So I'm going to go ahead and rewrite this real quick. And you just continue the pattern. So 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 0 is 1. 1 plus 0 is 1, 1 plus 3 is 4, 3 plus 3 is 6, 6 plus 1 is 4, and then there's a 1. So row 0, row 1, row 3, row 4, row 5, oh, hello, I missed row 2. Hold on. Row 2, row 3, row 4. Okay. And now we could take a look at row 5. So it'll be 1, 5, 10, 10, 5, 1. And that's row 5. So we're going to use this with binomial. So bicycle, bilingual, bi means 2. Okay. And this would be to represent our exponent in the binomial. And you'll kind of take a look and see what I'm talking about right now. Okay. So let's say I have a plus b. If it's to the power of 0, anything to the power of 0 is 1. That will always be true, no matter what. Anything to the power of 0 is 1. That's why we started off at row 0, and that's why we end up getting a 1. Okay, so let's say we have a plus b to the power of 1. Anything to the power of 1 is itself. But the biggest difference is that there's this one here, there's only a 1. This one here, there's a coefficient 1, a coefficient 1. So there's, without us even doing anything, there's an imaginary coefficient 1. Now let's say we looked at the next one. We have 1, 2, 1. And that's row 2, so it's a plus b to the power of 2. So for something like this, we could FOIL, right? And I'm going to show you what it looks like with the foiling, just to remind you. So it's first, outers, inners, and the last. There's 2 of these imaginary coefficients of 1, so we can add those 2 coefficients to get 2. So a squared plus 2ab plus b squared. Okay, so that is that foiled out, but, well, for these are pretty simple because they're pretty small. Once you get to like higher levels, obviously foiling's super, super impractical. So those are still going to represent our coefficients, but the way it works is that you're going to have a to the highest power, which is 2, and then you're going to have b to the power of 0 plus a to the power of 1. A is going to go up 1. I'm sorry. A is going to go down 1. B is going to go up by 1. And then we continue the pattern until you run out of your B's. So run out of your A's. So I have A0, B squared, and that matches my coefficient right here. Now, where this Pascal's triangle comes in is that there's going to be 3 separate parts right here, and that's your 3 coefficients. So it's going to be coefficient 1, coefficient 2, coefficient 1. A plus B squared, it's pretty small, so obviously foiling would make more sense, but bear with me while I'll show this to you guys. It's a little bit simpler when we have a lower number, and then I'll show you guys the higher numbers. So we can simplify this to 1 times anything is 1, b to the power of 0, 1, so that's just a squared, plus 2ab. We don't need the ones are given, or it's kind of not given, but it's understood. And then the 1 times anything is 1. A to the power of 0 is 1. 1 times anything is that same number, so we're just left with b, because this is equivalent like 1 times b squared. So it doesn't change the value of b, so we could just simplify it to b squared. So that would be your a squared plus b squared equals, and that would be your answer. And actually, I can highlight those as well. Okay, and I'll use different colors for the next ones because that's when it really gets intense. Okay, so a plus b to the power of 3. So let me show you that one. Because otherwise you have to FOIL it and then multiply it by this. 3 is still achievable. Once you get 4 and up, you're like in a whole other territory. Okay, so same thing, a to the power of 3, a to the power of 2, a to the power of 1, a to the power of 0. A goes down 1 every time. Now b is going to go up 1. So b started off with 0. Okay, now we're going to add in our coefficients. So for this one, I'm feeling blue. We'll do blue. Okay, so 1, 3, 3, 1. These are going to be your coefficients. 1, 3, 3, 1. Okay. Great. So now we just simplify. So this 1 times a cubed times b to the power of 0, it's like 1 times 1 times a cubed. So we can just reduce that to being a cubed. 3ab1, a squared, b, and we don't need the 1, it's inferred. 3ab squared plus b cubed. Okay, so this would be your answer right here. So Pascal's triangle essentially gives us all our coefficients, so we're able to solve these binomials. Okay, so let's take a look at the next row. 1, 4, 6, 4, 1. Okay. This is the power of 4, so a plus b, power of 4 is equal to, I usually like starting off with this, a's, because then I could count down and then count up with the b's. I'm just leaving this blank just so I have enough space to properly write everything out. And I'm not squishing myself at the end. And also right now we're just doing plus. You'll see later, I'll do an example when it's not a positive a and a positive b kind of in the binomial. Okay, now we're going to do our b's. So starting off 0, 1, 2, 3, 4. Oh boy. Okay, so now is when we can do our Pascal's triangle. So 1, 4, 6, 4, 1. 1, 4, I don't need these lines. 1, 4, 6, 4, 1. Oh, I guess I didn't need that big of a line. Okay. I'm going to match the colors so we can kind of color coordinate. It looks pretty. Because that's the only reason why. Just kidding. Okay. So those are going to be the corresponding coefficients. Now, same thing as before. It's really not that difficult. As long as you understand that anything to the power of 0 is 1, multiplied by 1 doesn't change the value. A to the 4th plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b to the power 4. That would be your answer. I should have enough room to do. I'll try to do the last one. Be tight. Okay. So I'll try to write small. A plus b to the power 5 equals something a5 plus something a4 plus something a3 plus something a2 plus something a1 plus something a0. Okay. So now we'll do B's. So B0, B1, B2, B3, B4, B5. Remember, this one matches this one, and this one should match this coefficient here, okay? Great. So now I can add my coefficients. 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. Okay, and actually I'm going to use a, so it stands out a little more. Okay, fantastic. Okay, so now we can simplify. So that's just going to be a to the power 5, 5, a to the power 4b, 10 a cubed b squared, 10 a squared b cubed, 5 a b to the power 4, b to the power 5. And that would be your final answer. Otherwise, you'd have to write it like this. One, two, three, four. 1, 2, 3, 4, 5. Okay, so it would be this for what we already did earlier when we did the FOIL, a squared plus 2a squared plus 2ab plus b squared. And then you have to multiply it over and over and over again. So you have to multiply this and then this. Then you combine like terms, and you have to do it again and again and again, and it's really way more time consuming, I guarantee it. Obviously, if it's power of 2 FOIL, 3 and above, you're definitely going to want to use the Pascal's triangle. Okay, so let's go ahead and take a look at some example problems. So this would be something like you might see on a problem. Okay, so let's say I have x plus 3y cubed. And I want that expanded out. This is binomial because it has two things being added together in the parentheses. So we're going to use our Pascal's triangle to solve. So honestly, these are pretty easy to create. So row 0, row 1, row 2, row 3. Okay. So I'm going to start off with my x, a little bit easier. So something x cubed, something x squared. Give myself some space after. Something x to the 1 plus something x to the 0. Okay, this is where it gets a little bit different. So we can put this in a parentheses. Parentheses 3y to the 0. Parentheses 3y power of 1. Parentheses 3y squared. Parentheses 3y cubed. Okay. And then we have our coefficients 1, 3, 3, 1. Okay. Whew. Looks dangerous. All we got to do is simplify. Okay. This is 1 times x cubed times 1. So I just get x cubed. 3 times x squared times 3 times y. I'm writing these out so it's a little bit easier to keep track because there's going to be a lot more going on when you have more variables. You have numbers versus letters. To me, it helps keep track, not necessary, but however you want. So 9x squared y, okay, plus 3 times x times, now this is going to be 3 squared y squared, okay? Remember, when there is a exponent that is on there, you can distribute the exponent if you have the multiplication in there. So it's going to be 3 squared y squared. So it's going to be 3 times 3 squared. 3 squared is 9. And then times 3 is 27. And then just one x and then y squared. So x, y squared. And then this is 1 times 3 cubed times y cubed. So 1 times 1, yeah. 3 to the power of 3 is 3 times 3, 9, times another 3, which is 27. So it's going to be 27 y cubed. This would be your answer. I don't like that line like that. Don't like that y either. Okay, struggle's real. The struggle is real. Okay, cool. That looks much better. So that's example problem number 1. And actually, I'm going to draw better lines in between the example problems, just so there's like a little bit better differentiation. Sure, that's good enough. Just so we kind of know we're looking at two different things. Okay. Oh, no, that is not what I wanted. Sure. Okay. Let's take a look at example problem number 2. Okay, so I'm going to have, I messed up, 3 minus x to the power of 4. Okay, so same thing as before, row 0, row 1, row 2, row 3, row 4. Row 0, row 1, row 2, row 3, row 4. Uh-oh. Okay. Let's take a look at these coefficients. So I'm going to have this 3. So instead of a letter, we're going to be doing with numbers. Something, 3 to the power of 4, plus something, 3 to the power of 3, plus something, 3 to the power of 2, plus something, 3 to the power of 1, plus something, 3 to the power of 0. Okay, so now we're going to do the same. I'm going to keep a negative x in parentheses though. Remember, this is a negative 1, okay? That might help Oh, man. Ugh. Kill me, Smalls. Okay, -1x to the 4th. Yucky, but whatever. Okay, so now I can add my coefficients. 1, 4, 6, 4, 1. Made too much space for the coefficients. That's okay. Just as a heads up for the coefficients, you know, another way to make sure you have the right row is the number of blanks should match the number here. So I have 1, 2, 3, 4, 5 numbers in my Pascal triangle. 1, 2, 3, 4, 5 blanks down here. Remember, this degree should match this degree over here as well. So we're doing the 4th row because we have a binomial to the power of 4. Okay, anyways. Anything to the power of 0 is 1, so that's times 1. 3 to the power of 4, so it's 3 times 3, which is 9, times 3, which is 27, times 3, which gives you 81. So 81 times 1 times 1, doesn't matter. Doesn't change the value of 81. So we have 4 times 3 to the power of 3, which is 27. Now this negative x is going to matter. So it's -1 times -1 to the power of 1, still the same value, x. So it's going to be 3 to the power of 3 is 27, times 4 gives us -108. I'm sorry, gives us 108. Now we're multiplying it by a -1, that gives us a -108. So -108, and we're just left with an x. Okay, so now we have 6 times 9. Luckily, your numbers are going down. Should be easier to manage. 6 times 9 is going to give us 54. Oh, and then also too, -1 squared. That's a negative times a negative, which is a positive 1. And then we also have x squared. So it's going to be a positive 54x squared. Okay, so now this is 4 times 3, which is 12, times -1 cubed x cubed. So negative times a negative is a positive, times another negative is a positive times a negative, which gives us a negative. Honestly, the easiest way for me to remember is a number squared is even, right? It's like -1 times -1. Negative times a negative is a positive. If it's an odd number with an exponent, with a negative, it's going to be a negative. If it's an even, it's going to be a positive. 3 is an odd, so it's going to be a negative. Okay, so it's going to be a -12x cubed. And then 1, don't worry about it. 3 to the power of 0 is 1. And then we have -1 to the power of 4. Same thing, it's even, so it's going to be positive. And then x to the power of 4. So now we have a positive x to the power of 4. And this would be your final answer.